has to do with sorting, so that E, lowercase e, is higher than uppercase H. And that's just because in the simplest of sorts, we just sort them numerically. So new line, if you go back to the previous little sheet, new line is this 10 right here. It's that 10, which is a line feed, and that's a 10. And that's why when we print new line out, we get a 10. And so again, in the early days when strings were simple, we just represented them as 1 byte per character. But the problem is that, you know, as we have gotten more complex, and in today's modern world, it's simply unacceptable to say that the only thing computers can understand is ASCII. And so this leads to a from the simplest of character sets to a super complex character set called Unicode, which basically is billions of characters, potential billions of characters for every language and every character set. And because there's so much space in Unicode, it's easy to take very small variations of characters and give them a space. It's so large that you can have you can have pretty much any character that you want. So that's Unicode. The problem is that if we sent Unicode across the network, it would be way too large. It'd be this UTF-32, which instead of being 8 bytes per character would be 4 bytes per character. And so it would take all of the data that we build and make it 4 times larger. And it'd be very difficult. And so what they've come up with is ways to compress this. And UTF-16 is this weird thing. UTF-32 is really sort of the full Unicode pretty much. UTF-16 is a subset of Unicode. It's used in some countries. But the best practice for moving data across the internet or in a file that you're going to move between computers is what's called UTF-8. And so what happens is that UTF-32 is fixed length. ASCII is one byte. UTF-16 is 2 bytes. UTF-32 is 4 bytes. And UTF-8 has dynamic length, meaning that it is 1 to 4 bytes. And if it's only 1 byte long, it's perfectly compatible with ASCII, meaning that an ASCII file is also a UTF-8. And so here's this little sheet, and it's not critical that you understand this graph too much, but basically as time passed, 2000 internet's coming, now 2014, pretty much overwhelmingly the documents on the internet that you might retrieve are UTF-8. Now, so UTF-8 is the recommended practice, and it's sort of a compression of UTF-8 can represent all the things UTF-32 can represent. It's just a compression of it, so that and with an overlap of ASCII, which is awesome. It's what you want. I don't even talk anymore. So in Python, we have always had sort of 2 ways of representing strings. In Python 2, the normal string was a byte string, was an ASCII string, was a Latin string. And if you wanted to represent Unicode, there was a separate kind of object that we had. And so you would do that. And in Python 3.0 or later, one of the main features of Python 3 was to make Unicode and string the same. So that means inside of Python, when you have a string variable, it's a Unicode. Whereas inside of Python 2, it was a byte variable. And so now we have this notion separately in Python 2 and on Python 3 where we have byte variables. And so byte variables are, in effect, an array of bytes. So if there's ABC, that means it's 3 bytes. It's 3 bytes long. Whereas a string might be a 3-character string might be anywhere from 3 to 12 bytes long. So Python 2 had bytes and strings that were the same. Bytes and strings are the same, and Unicode is weird. And in Python 3, strings and Unicode are the same, and bytes are weird. Okay, and so that's what we've got to deal with. And there'll be times when we get bytes from APIs. When we call things, we have to then figure out what kind of thing those bytes contain, because the bytes might contain ASCII, they might contain UTF-8, they might contain various things. And so internally, all the strings in Python 3 are Unicode. Most of the time, if you're inside the program or reading and writing files, we just work. And that's why we haven't mentioned it. But now that we're talking over sockets, and we're talking to the sort of random world out there, we have to be a little more aware of the data we're dealing with. Now, the good news is 98% of the time, or 95% of the time, it's UTF-8, which might also include ASCII, and so it's quite nice. But we have to be aware of this. And so if we are going to take data that comes off of the network in the bytes, then we have to make sure that we interpret it or decode it and in the right way so that internally the strings, which are Unicode, are properly represented. And so that's why when we read data in from a network connection like a socket, we have to say, hey, decode it. Now there's a couple things going on at that moment of decode. And so this is where we're doing it. We see this, we have to manage this in this code where before we send this stuff, we're going to encode it, which takes a Unicode string and turns it into UTF-8 bytes. There's actually a parameter here that you could do it different than UTF-8, but no one ever does. You might have to for certain situations, but so that says that we're going to encode this into UTF-8 before we send it, and then when we get something back, before we print it, we're going to decode it. And that's how this ends up working out. And if you look at the documentation, you will see that sometimes it says it's a string or it's bytes. And so, you take a byte array and you decode it to get a string, and you take a string and encode it to get a byte array. And so that's what we're doing. So you can think of the process as this way, and that is the network has these UTF-8, mostly UTF-8 resources, not ASCII. If it's ASCII, it's okay. So you read with the receive. So this receive here pulls data, or well, we have a Unicode string. Let's start with the send. So up here, we have a Unicode string. That's a Unicode string, even though there's no special characters in it, no Asian characters or French characters. That's a Unicode string. And before we can send it, we have to send it in UTF-8. If that had Asian characters, it'd be okay, and that would be set up just right so that the UTF-8 would be right. So we encode it first, and that's this CMD. This is now bytes. Okay, CMD is bytes, and then we actually send the bytes, and that goes across the network. We get back our thing, and we receive into data. Well, data is bytes, not string. It's bytes. We can say how big it is. Functions kind of like a string, and it has len, except that it is 1 byte per character, which means some of it might be UTF-8. And then all we have to do is say decode. Again, you could, if you were dealing with a situation where you weren't expecting it to typically be UTF-8 or ASCII, you could tell it UTF-16 or something, and it's more complex. But the simple thing is you just say, I'm going to clean up my data on the way in, I'm going to clean it up by running it through decode, and I'm going to encode stuff on the way out. And so sockets are the place where this comes into play. And so you'll see we'll always do this encode and decode every time we're sending data kind of outside of Python and inside of Python. So now that we've talked a little bit about character sets, we're going to make this even easier so you don't have to use sockets. URL-lib is a bit of Python code in the library that does all the socket stuff for you. Okay, so now we're going to write a web browser again in Python, but it's going to even be shorter than what we did before. We did it in 10 lines using sockets. Now we're going to do it in 4 lines with URL-lib. So URL-lib really is just because the idea of opening a connection, sending a GET request, sending the new line, retrieving the stuff, breaking the headers out, doing all this stuff, that's so common, why not put it in a library to save ourselves some effort? So here's how we do it. We're going to read it in, right? We're going to import this library, so it's not we had to import sockets before, but we're going to import URL-lib now. And so this is really quite simple. It's like elegantly simple. You say URL-lib, that's a library, that's a part of a module within the library, and this is a function. So let's call URL open, and then give it the URL. Now that's a string which it's going to encode automatically for us. So it's taking care of all kind of pretty things for us. It does the get, it does the encode. Look back at that previous code. That's kind of what URL-lib is doing for us. Okay. Now what URL-lib also does is it makes the connection, encodes the GET request, and then it actually retrieves, at this moment, it retrieves all the headers and keeps them for you for later. You can get the headers, but we're not going to see the headers. And it returns to you an object that looks pretty much like a file handle. Because you can put this in the for clause after the in. Now it's going to read